So this video is going to cover 3.1 with the complex numbers. So first we have a definition of the number I, and this is defined such that I is equal to the square root of -1 and I squared is equal to -1. So these two things right here you're going to want to have memorized. Okay, so let's look at example 1. We want to express each number in terms of I, okay? So we know that I is equal to the square root of -1. So over here, basically what's happening whenever you have a negative, since there's a negative here and it's underneath the square root, you can pull it out and let it be equal to I. So since there's a negative underneath the root, I'm going to pull it out and make it an I. Okay, once you've written the I, you just get rid of the negative. So then we'll have root 7. Perfect. And that would be simplified. Okay, for the next one, we have a negative again, so I'm going to pull it out as an I and then leave the 16 underneath. We know that the square root of 16 is 4, so I'll write this as 4I. It's okay if you write I4, but you'll generally see the number written before the imaginary number I. Right? So for the next one thing to note is that you already have a negative on the outside, but we have this negative on the inside, so we'll pull this negative out as an I, and this negative will stay, right? So we'll have this negative because of the outside, and then we'll have an I because of this negative on the inside, and then the remaining number is that 13. And we cannot take the square root of 13, so that would be it for that one. Okay, for the next one, we have this negative, so we leave it. This negative on the inside will change this to an I, and then we have that 64. We know that the square root of 64 is an 8, so we'll have -8I. And then last, we have this negative, so that's going to come out as an I. We're left with 48, and then we'll have to figure out how to break up this 48, okay? So 48 is the same thing as 16 times 3. And we know that the square root of 16 is 4, so we're going to pull it out. So that's going to leave us with 4I, and then that 3 stays underneath. Right, so next we have the definition for complex number, and that's going to be in the form A plus BI, okay, where A and B are both real numbers. A is going to be your real part, and then the B is going to be your imaginary part. So for example 2, we want to be able to add and subtract these things. You're going to do this just like you do all the other problems. We have parentheses, and we need to get rid of those parentheses, and the way that we do that is distribute, right? And before we distribute, we check the powers, but there aren't any powers. So we're just going to distribute what's right in front of the parentheses. There's nothing here, so I'm going to drop my parentheses, and here there's a positive, so that means I'm going to distribute that positive to both of my terms and then combine like terms. Again, your A is the real part, and then your B is the imaginary part, so you're going to combine those separately. So we'll have an 11 and then plus 8I for the imaginary part. All right, I want you guys to do example 2B, and I'm going to move on to example 3, okay? Here we want to multiply. So for this first one, we have the square root of -16. Remember, because it's negative, we can pull that out as an I, right? So we'll have an I, we have the square root of 16, and again here we have a negative, so that's going to be times I square root 25, okay? We can take the square root of 16, which gives us a 4, so we still have this I, so that's 4I times, and the square root of 25 gives us a 5, so we still have this I over here, so that's 5I, okay? Since we're using multiplication, we can combine these things. We have our 4 times our 5, which gives us a 20, and then we have I times I, which gives us I squared. And then remember from our definition, I squared is always going to be equal to -1. So once we get to this point, this is going to be equal to -20 for the final answer, okay? Well, I kind of want to box my answers. All right, cool. And then for example 3. To be able to multiply this, we're going to have to use our magic word, right? Foiling. We have 2 terms here and 2 here. So we'll do positive 1 times positive 1, which gives us a 1. And then we'll do positive 1 times positive 3i, which gives us a positive 3i. Positive 2i times 1 gives us a positive 2i. And positive 2i plus positive 3i gives us a positive 6i squared. So that's something to be really careful about when you're foiling. You're always going to get that squared at the end when you multiply your when you multiply your i's together, okay? So here we can combine our like terms. So we'll have 1 plus 5i, okay? It's not going to be squared. You're just combining like terms. And then here, remember, again, our I squared is equal to negative 1. So whenever you have I squared, you can think of it as changing the sign, okay? So because this is plus 6, it's going to come out as negative 6. And then again, we can combine our like terms, this 1 and this negative 6, to give us negative 5 plus 5i. Okay? Okay, cool. So moving on to the next question. We have some simplifying to do. Right, so basically with these ones, what you want to do is remember, again, that our I squared is equal to negative 1. So we want to be able to change all of these to a power of I squared, okay? The reason why we want to do that is because it's going to give us a negative 1. And when negative 1 is raised to an even power, that's always going to come out as a positive 1, right? So if you had negative 1 squared, that's going to be positive 1, right? If you have negative 1 to the 4th, that's also positive 1. And then if it's raised to an odd power, that's always going to come out as a negative 1, right? So what we can do here is rewrite these. In this case, we have an odd power, so we'll need to split this up into 2. So we have I raised to the 36 times I to the 1, okay? Whenever you have 2 bases, you're able to add these 2 numbers. So we can add those to get the 37, so this will work. And then from here, we can change this I 36, raise it to the 2, which is what we were trying to get to, and figure out what it has to be raised to give us that 36, okay? So that's going to give us 18. Since we only have one base I, you're actually going to take this 2 and 18 and multiply them to get the 16. So when you have 2 i's, you're adding them to get this 37. And when you only have one I, you multiply the 2 numbers to get the number, okay? And we still have this I to the 1 on the outside, okay? As we simplify this down, we know that I squared is the same thing as negative 1. It's raised to the 18, which is even, right? And then it's being multiplied by just I. Whenever it's even, we know it's going to come out as a 1. So for the final answer, we'll just have I. Right? So for the next one, we have I raised to the 58, excuse me. It's already an even, so we'll be able to split it up from the jump. So we need to come up with a number where we can multiply it by 2 to get that 58. And that's going to give us 29. Again, since there's one of them, 1 means multiply, 2 means add, okay? So here we're multiplying these 2 numbers to get that 58. We know that I squared is the same thing as negative 1. This number right here is odd. And we know that negative 1 raised to an odd power is negative 1. All right, so let's do the next one. We have I raised to the 75th power. It's not an even, so we're going to have to split it up. So I'll do 74 times I to the 1. 2 means add, right? Okay. From here, we need to figure out how we can change this I to the 74 as I squared raised to something. So what can we multiply 2 by to give us 74? And that would be 37. So 37 times 2 gives us 74. And we still have this I on the outside, okay? This I squared is going to give us a negative 1 to the 37. And then we have that I, okay? This 37 is what, even or odd? This is odd. So we know that this is going to come out as a negative 1. So we'll have negative 1 times I, which is equal to negative I, okay? So I'm going to leave example 4D as an exercise for you guys, and we'll move on to the next thing. All right, so now we're going to talk about the conjugate of complex numbers. So basically, whenever you have a plus bi, the conjugate of it will be a minus bi, or vice versa. If you have a minus bi, the conjugate will be a plus bi, okay? And we'll look at some examples in a second. Okay, so here is a perfect example. We have 5 plus 7i and 5 minus 7i. So we're actually multiplying conjugates together. We're going to do that by foiling, right? So we'll have 5 times 5, which is 25. And then we'll have 5 times negative 7i, which is negative 35i. Then we'll have our positive 35i. And last, a positive times a negative is a negative. 7 times 7 is 49. And I times I is going to give us that I squared. Remember, this I squared is changing your signs, okay? So instead of a negative 49, we're actually going to have a positive 49, okay? And the cool thing about multiplying with conjugates, your middle terms of your FOIL actually cancel out. So these two terms will go away, and we're left with the F in FOIL and then the L in FOIL. And here, again, since this is I squared, it's going to change the sign to a positive 49, okay? So for our final answer, we'll just add those things together and get 74. Okay, I want you guys to do example 5B, and then I'm going to do this last example. All right, here we want to divide two complex numbers. And the way that you do this is you're going to multiply the top and bottom by the conjugate of the denominator. So since this is a minus, the conjugate has to be plus 6i, okay? And then we're going to FOIL on the top and FOIL on the bottom, okay? So we do 2 times 1, it's just 2. 2 times positive 6, which is 12i. Negative 5 times 1, which is negative 5i. Negative 5 times positive gives us a negative 30i squared. And then on the bottom, we're multiplying by the conjugate, so we know that we can just take that first one and then do the last one. So that's going to be 6 times 6, which is 36. I know that it's negative, but remember those I squareds are going to change it to a positive. So it's always going to be the first one squared plus the second one squared, which is going to be 36, okay? So now on the top, we have this 2. Our 12 minus 5 will give us a positive 7i. And then remember, this I squared is going to change the sign. So instead of minus 30, we'll have plus 30 over 37. And then we need to combine like terms on the top still. So that's going to be 32 plus 7i divided by 37 for the final answer, okay? One thing to be cautious about is simplifying these. Remember, there's 2 parts on top and 1 on the bottom. You can only cancel things out or simplify if all 3 of them had something in common, okay? But that's it.